Hello everyone, this is the first lesson recording for IM2, September 2nd, 2020. So if you are watching this video, you are either watching it to rewatch some of the portion or because you were absent. So if you were absent, you should go to studentdesmos.com and type in the class code S6WBU3 if you're in period 1 or 5YYQWP if you were in period 2, so that you could get access to the Desmos activity slides. Okay, so as part of your warm-up, you are going to do the first 11 slides. They are pretty quick, so you have about 7 minutes to get as far as you can get done, please. And while you're doing that, I'm going to give some announcements. So quiz retake was and is today, which is Thursday, September the 2nd during study hall. And so if that is you, then please let Mrs. Van Horn know so that she knows to expect you. Next week, Monday is a public holiday due to Labor Day, so that means we do not meet on Monday. We actually meet on Tuesday. Tuesday becomes the A day, so period 1 and 2 and 3 you are going to have on Tuesday, and period 4, 5, and 6 you are going to have it on Wednesday instead of Tuesday. So please keep that in mind. That means also the homework is also due on Monday night instead of Sunday night. Homework, classwork help, I've said this before, but there's also always, I am always available during my study hall so that we can get started with the homework. This afternoon we'll get started with the quiz retake, but we will also get started with the homework as well. We also have master tutoring for by the qualified student tutors, and you can go to the Zoom link here, and I've sent an announcement to each of my periods, so you should be able to get access from there. You can also rewatch the lesson videos or other online resources. Okay, I am going to quickly go over the homework now. Okay, so the homework was for you to watch some videos, mathematics videos, and write down, fill in the graphic organizer with all the definitions and descriptions and diagrams and notations. So I am just going to quickly go through them, point out some key things. The notation for line segment is AB with the bar on the top, and you should have this diagram as well as diagram for lines with this arrow going both directions, and then ray, and followed by parallel lines. This is something that they did not show very well, but I do want you to add this to your notes if you do not have it. The notation that tells you that two lines are parallel is this arrow notches. Okay, so these two arrow notches tells me that line AB is parallel to line CD. And how do you write that? You write AB, line AB is parallel, that is a parallel symbol is to line CD. Okay, then the next page should look like this. Everything is pretty straightforward. And then again, for perpendicular, the symbol for perpendicular that tells you is that 90-degree angle symbol. And how you write that as notation is BD is perpendicular to AC. Everything else is pretty self-explanatory. Okay, you may pause the video and write down anything that you might be missing or anything you might be lacking. Okay, so make sure that you have the complementary angles and supplementary angles. And by the way, the complementary angles and supplementary angles, they do not need to be next to each other in order for them to be complementary or supplementary. Okay, and then finally the last video walked you through triangles, definitions of triangles and different types of triangle. And here they are. As far as the notation goes, there isn't much of notation. What is important is the notation on the diagram. Equilateral triangle, these notches tells me that this line segment is same in length as this line segment, as in same length as this line segment. And likewise for the isosceles triangle with two sides, equal sides lengths. So that means I can put two of those notches to indicate that this side length is congruent or equal in length to this side length. And then scaling, none of the side lengths are equal, so I am going to indicate that with 1, 2, 3. So they have all different number of notches, which means that they all have different length. And finally, the triangle angle sum theory that they walked you through, that sum of all interior angle of triangle is 180 degrees. That means angle A, that's the angle, the red marked angle, plus angle B, and angle C is equal to 180 degrees. Okay, at this point, I would have walked through all the answers to Desmos. And so then we are going to get started with the learning for today. What are we doing? We started off with a linear equation review warm-up, and then we went on to geometry vocabulary and notation and review, and we're going to go into algebra problems using complementary and supplementary angles, triangle angle sum, and exterior angles. And we will also revisit linear equations as well. Okay, so by the way, there will be a quiz next Tuesday when you come back on linear equations. That's just simply very similar to the warm-ups that we did that you should be able to do at this point. All right, so resource for today's lesson. There is a geometry textbook module in Canvas, and it's from chapters 1.5 to 4.2. 1.5 and 4.2. So what is this geometry textbook? If you go to your module in Canvas, you're going to see this right at the top of all the modules. So there is an algebra textbook. It's by Glencoe, and geometry textbook. So currently this new unit is on geometry. So if you click on the geometry right there, then you are going to get different sections, different chapters. Okay, so I said 1 point something and 4 point something. So you are going to go to those sections if you need any textbook help. So this is different from CPM textbooks. They actually give you explanations more thoroughly. So you will find this a lot more useful than CPM textbook. All right, and I've said this about the quiz next week. So on solving equations and linear relationship representation, can you solve the warm-up questions comfortably? Can you solve two-step, multi-step equations accurately? That's going to be what's on the quiz. What is an angle? Okay, let's get started with the geometry today. Okay, what is an angle? Well, before we get started with an angle, angle is formed when two rays share a common endpoint called vertex. So we have a ray here and another ray here, and there's a vertex. That's the point that both rays share, and that is the space in between the two rays. That's called angle. And you can represent angles as colored space like so, or you can also represent it as a curved line or arc in space inside the two arms of the angle. A point is in the interior of the angle if the point lies between the two arms of the ray. Okay, that's interior. So point D is the interior, or exterior, that means outside, right? So exterior, or point E is outside of this angle. So we call that's an exterior point. So we're going to start learning a lot of vocabulary, and geometry is a lot of vocabulary, but it's not just, there are words that have meanings, as in that you can think about and you can come up with. So don't just try to memorize them brute force. Try to connect to what you already know. Interior means something that's inside. Exterior means something that is outside. Okay, so we're going to skip that. So what is an angle? how big is this angle? So in order to measure this angle, how can I measure it? Well, if I measure from here, it's going to be like 2.5 centimeters. If I measure from out here, this is going to be 6 centimeters. Okay, so depending on where I measure from, if I just use the ruler, I am going to get different measurements. Okay, we can't have that. So what do we need to do? We need to use degrees instead, using a protractor. So if I brought this protractor over here and then measure how wide, how much of a space it is, it's going to give us the measure of how big the angle is. Okay, it doesn't matter from where we measure the degrees. No, it does not matter, because it's going to be the same, unlike using the ruler. So using the protractor will give us the same angle regardless of where you measure it from. So what's an angle? It's a circular space between two intersecting rays. And why is angles really important? Well, what is the most common types of angle in most rooms, or basically your house or anywhere? It's the right angle. So right angle you're going to see everywhere, and that's going to come really handy for many things. So that brings us to what is complementary angle. Below are some examples of complementary angles. Notice that 64 and 26 degrees, they form together. They add together to be 90 degrees. 53 and 37, they are also 90 degrees. And 32, 38 and 52 and 63 and 27, they all add to 90 degrees. And that's what complementary angles are. They do not have to be right next to each other like here. They do not have to be sharing a ray. They can be two separate angles, but when they add to 90, we say they are complementary angles. So we say complementary angles are two angles with measures that add up to make 90 degrees. You should have these notes in your graphic organizer, but the angles don't have to touch to be complementary. Okay, so find the measure of angle B. How do I do that? Well, I know that this is going to be a 90 degrees because I know that this angle is marked as 90 degrees. We know that the straight line is going to be 180 degrees. That means we know this angle has to add up to 90 degrees, because 90 plus 90 is 180. So if you know that they add up to 90 degrees, then we know that 41 plus B is equal to 90. That's the relationship. And then we subtract 41 from both sides and get B to be 49 degrees. What about this? Okay, it looks a little bit more complicated, but it's the same thing. It's just algebraic expression instead of some number. We know that this angle, and we are told that it is given in the algebraic form of 2x plus 3 expression, and this angle add to 90 degrees. Because how do we know that? Because of that symbol, that square symbol right there. So that means 2x plus 3, that angle, plus 5x plus 3 is 90 degrees. And we don't need the parentheses because they are all just adding. So then from here, I'm going to combine like terms. 7x plus 6 is 90. And then we're going to solve algebraically, subtracting 6 from both sides and then dividing by 7 on both sides. That gives us x to be 12. X to be 12. Okay? Alright, what about supplementary angles? Supplementary angles, in contrast, add up to 180 degrees. How do we know? Because this is a straight line. The angle A plus angle B, they form straight line. So they have to add up to 180 degrees, because straight line is 180 degrees. So this is something that you have not taken notes on. So linear pair postulate, if two angles form a linear pair, then they are supplementary. Please take this down. Okay, and take down the notes and the diagram as well, please. Okay, and what's the difference between postulate and theorem? Postulate is a statement that is accepted to be true without proof, and a theorem is a statement that can be proven through